Good morning, everyone. For today, we need to complete structs. We need to review some examples of the structs. And the next step is going to be talk about data structures. My assumption is that you are aware of what is a data structure, in particular, that you know linked lists, maybe stacks or queues, and maybe trees. This is not a data structure class, so I assume that you know them. And the only thing that we need to do is to review how to create, in particular, this, maybe this, using C, using pointers, using struct. So it's kind of a combination or a pretext to combine those two and see what happened. But first, let's review structs. The structs. I described what is a struct, and in the previous lecture, we agree is kind of a class without the methods, the grandparent of classes. So far, easy. This is the most important thing that you need to remember for your exam, and in general, to be able to work with the structs. Now, examples. Two important things for you to remember in the code. Number one, instead of using the keyword class, well, we use the keyword struct. Everything else is kind of the same, except for one thing. When you create a struct, you open curly bracket, close curly bracket, but also you put a semicolon. In my example, struct person, you will notice open curly bracket, the variables, closing curly bracket, and there is a semicolon there. It should be there. This is something that is going to be different from what you did in Java, and this is going to happen the same with the structs, and later, when we move to C++, the same is going to be needed for the classes in C++. So remember, structs now, classes later, we will need the semicolon at the end of the declaration of a struct or later a class. That is maybe the most important difference. Anything else, the same. You can have several different variables inside. You put for each of those variables the data type and a particular name, whatever name you want. Inside, you can have primitive variables, or you can have arrays. Later, we're going to review examples. You can have pointers. Any data that you want to use can be part of a struct. Right now, we do not have objects, but later in C++, we're going to be able to create objects, have classes, and we can put objects, classes, inside of a struct, or a struct inside of a class. Different tools. Good. So step number one, you create the struct, define the variables that are going to be inside. Then, in order to use the struct, this is important. In C, you use the name of the struct, just like the name of the class in Java. But also for C, you put the keyword struct there. So when you want to create the variable, you put struct, the name, and then your variables. If you are using a C++ compiler, it's going to be okay if you do not put struct, if you only use, in this case, person. If you only put the name of the struct, it's going to be okay because the IDE that you are using. But in general, the rule is when you want to create a variable, you put struct with the name, struct person, X and Y. What is going to happen is X, and I am going to use circles, just like with objects, and Y, These two variables are a combination of one integer, that is the ID, and one array with 30 characters each, that is name. That is X and Y. That is what I am doing here inside of main. And because they are inside of main, these two are local variables. They are in the stack for main. Local variables, the name is the name of this set with all the variables, ID, name in this case, that we create for the struct. The struct, a set of variables, and they are not the same type like the arrays. If you look at this, it's the same representation that we usually do for objects, a circle, a collection of variables, the attributes, that's it. But here, we do not have methods, and we can create the struct in the same file that we are creating our program. There is no need for one file with the name of the struct and things like that you did with Java, right? Notice, very, very important, the main is not inside of the struct, it's not a class. This is one thing, like variable declaration. The struct is kind of global. The struct go outside of the methods. The struct go above, below, but outside of any method. Is part of the program, but it's not inside of any of the methods, not the main, no other. And then here, global, or here, local, you can create variables using the structs, just like objects using the classes. And you're going to have something like this. After you create the variable, well, you can use the variable. And the rules that we know apply the same for the struct. For instance, if you want to use a scanf to read values and store those values in the struct, well, can you tell me why I am using here the ampersand for the scan %d, the ID in X, and why I am not using the ampersand here to read with the scan a string that I am going to store in the array of 30 characters also inside of one of the variables? Did you notice one have the ampersand, the other do not have the ampersand? Yes. You remember, right? This one, name, well, name is really this box pointing to the elements. This is one box pointing to the elements. So X, this is X, and name is a pointer. I do not need the ampersand for it. I do not need the ampersand for the name in Y either. But for the ID X inside ID, this is just a variable. And for the variable, we need the ampersand to get the address. So name, ID, that's it. Now, if I want to print, similar thing that you did with objects, the name of the struct, the set, and the name of the element with, and we mentioned before, the dot. The dot that you use for classes and objects is going to be back, well, really, the dot exists because the structs, and later they use the dot for the classes and objects. You can print, you can scan. The only thing is now those variables are part of this group, the struct. Good. So this is my first example. One struct, one main, scan, print, using the variables inside. That's it. Something more elaborated, complex. Hopefully now you can read this and putting together all the things that we have been reviewing. maybe makes sense what we are doing. Let's see. Number one, the library. You know the library. I am going to be using scanf and printf. That is the reason of that library, right? The struct, you can notice the struct outside of any method, usually at the top of the program. Struct and the name, open curly bracket, closing curly bracket, and the semicolon. Mandatory. If not, your compiler is going to tell you an error. You need the semicolon there. Now, the variables. Now I have this struct with a name, a phone, and an email. 2 arrays, 1 primitive data, integer, just to play with them. And also, what is this? Hopefully you agree with me. Number one is a variable. It's a variable and it's outside of any method. It's a global variable. Variable outside of the method is global. What is the type for the variable? Well, the type is contact, but because it's a struct, the rule is the type is the name, but also the keyword, struct. All this, struct contact, is the type for that variable. Again, if you are using an IDE that works with C and C++, probably if you write only contact without the keyword struct, it's going to compile fine. But my recommendation, the rule, if you are working with the struct, the name of the struct and also the keyword struct when you create your variables. That is a very good question. What is going to happen with size of? We're going to show you. The data type. And then the variable. The name of the variable, contact underscore book. Maybe you notice that the variables in C. In Java, the rule was if you have 2 words, put uppercase, the first letter of the second word or the third word or whatever. So everything together and use the uppercase to help the reader to check how many words and in which point one word start and the other end. That is something very particular with Java. That is the style in Java. For C, usually you never use uppercases for names of variables. The names of the variables, even the name of the methods, are always lowercase. And when you have more than one word, what you do is using the score, lower, as white space. You're going to notice in the textbook, in general, if you read source code in C, that they use a lot the underscore, and it's kind of to represent the white space. But you cannot have white space, right? So contact underscore book, like 2 words together with the underscore, instead of the Java version that could be Java C. Now, remember, these are recommendations. You can follow the same style that you use for your variables in Java here. You can change this for this, and it's going to work. At the end, both IDs are fine according with the lexical rules. The only thing is, well, if you're working with Java, it's a good idea that your programs look like Java programs. And if you're working with C, it's a good idea that your programs looks like C programs. So my recommendation for you is, when working with C, follow something like this, and in Java, something like this. So the people understand that you are not a Java programmer trying to do something with C or vice versa, but you are full in the language. Anyway, it's an array. It's an array of 100 elements. is a global array, 100 elements. Questions for your exam. That one is a global variable. Is in the heap, the data, or in the stack? And how do we know? Heap or stack? Is global. Stack. How do we know that it's in the stack? There is no malloc, right? The only way to put something in the heap is if you have malloc. I do not have malloc here. Now, I need to be sure. This array looks like this and 100 elements. I am not going to draw everything. 100 elements, and you can imagine that each of the elements is a contact. Each of the elements is something like this and have inside a name that is an array with several elements, an integer, and another array with several elements. That one is the element 0 in the array, the first element. All the others are the same. You have an array, and in each position of the array, you have this group of variables, including other 2 arrays, right? It's kind of the same that with an array of objects, but now they are not objects. Moreover, the important thing here is this variable. This variable, always, always, always an array is the elements, in this case 100, but also this guy, the pointer, because always, always, always an array is a pointer. Can you tell me what is the type of this pointer? Because this guy, the circle, is a struct contact. This one is contact book. What is the data type for this one? Thank you. Yes. This one, this variable, is a pointer. It's a pointer to a struct contact. It's a struct contact asterisk. Remember, if you have an array of integers, what you have is a pointer to integers. If I have an array of a struct, what I have is a pointer, and the data type of the pointer is the struct, in this case, struct contact asterisk. Okay, the size. If you want to calculate the size, yes, this element here is according with this 64. If I am asking for an array of 100, 164, something like this. Now, this is theoretical. Why? Because this struct need space to complete the struct. Think about this. You have a box, and inside of the box, you have elements. The size of that is the addition of the size of the elements, but also the box, the enclosure, adds some space. How many space? Depend on the operating system. So theoretically, your size, and if you're running this in your IDE, it's going to tell you maybe this. But if you really measure how many memory you use when you do something like this, sometimes this is just an approximate value, and most of the time is more than this, because the segments, because the struct, because the encapsulation on all this. But yes, theoretically, at least for theoretical purposes, the size of this is 64, each element, 30 plus 30 plus 4, and 100 times that. Yeah. Good. Now, I have the array. The array is global. Now what I want to do is to use the array. Do we understand what is this? Name of the array, this. An index, whatever is the index is one of these. And then the dot, I am here or here or here. And with the dot, I am going to move to one of these elements, right? Square brackets to get a position in the array, the dot to access one element in the struct. I can use this for the phone, that is an integer, therefore I need to use the ampersand, or I can use the name and the email without the ampersand because they are arrays. Tricky question for your exam. You know what? I have this array, and what I want to do is to put in the name that is in the first element of the struct here, I want to put a letter A. Only the letter A. A character. And I want that in the first element of the array, the second letter in the name. What could be the instruction that I need for that? The first element in the array, the second element in the name. Well, you want to access the first element in the array. The name of the array is contact book. So this one is the array. This one is the first element. Now, you want to access name. In order to access name, you need the dot, name. And what I need to do to put the A in the second element of the name? Well, something like this. Can you agree? It's like, are you using square brackets 2 times in one line before the equal? Yeah, because I have an array inside of another array. So the first 0 is for the position 0 of my array of structs, but then the element that I am accessing, name, is another array. So I can use another square brackets to move in that array. And it's an array of characters. So this guy is going to go to the second position in the array of characters. I cannot put a string because the element itself is a character. I put a character, single quotation marks. Makes sense. Practice with this. Tricky arrays inside of arrays. And we need to review structs inside of the structs. But more or less, this is going to be the model. Scan the ampersand only for the integer and print. And I can print strings or numbers. What happens if I want to print only the second element of the name, the second character in the name for one of the elements in my array? I can put something like this in a print instruction, right? I can ask for a particular element in the array of structs, and I can ask for a particular element in one of the arrays inside. In this case, characters, but you can think about your grades, a struct student, and one variable that is grades, and maybe grades are 5 grades because there are 5 homeworks during the semester, whatever, or an array of 3 because there are 3 exams, maybe, something like that. And you want to access the grade for the homework 1 or the grade for the homework 2, the grade for the exam 1, the grade for the exam 2, arrays inside of one element student, and then you can have a collection of students, right? So, moreover, continue with the example with the students. I can create something like this, X, or something like this, Y. I need to be sure that we agree. When you create X, X is something like this. X is what I represent as a circle. In this picture is a box. When you create X, you are creating the name, that is the array with all the elements. You are creating the variable int, that is the font. You are creating the email, that is another array with the pointer and all the elements. When you create X, this is what you are doing. This X is this thing, all the space for the data in order to start working with the struct. When you create Y, Y is a pointer. And as you heard me before, the type for the pointer is all this. But it's a pointer because the asterisk, just like we reviewed before. And this Y is just a simple box that is going to store here an address. It's not a struct. It's not a circle. Do not have a space for names and phones and emails. It's just one single box. And if you ask for the size, tell me, what is the size of X? Probably 64. If you ask for the size of Y, what is the size of Y? Oh, asterisk Y. The size for Y maybe is used for the size of an integer storing the address. This is a big difference. The size of the struct X is the data, all the space to having the data. The size for the pointer is just this green box here storing the address of the first byte in which this struct is stored. So this is nothing but one box. This one, Y, do not have names, phones, emails, nothing. Is a place to store an address. Now, well, what you can do is two things here. Number one, you can make Y equal to the address of X. And when you do that, this is pointing there. And after that, yes, if you ask, if you compare them like Y asterisk Y dot phone equal X dot phone, this is going to tell you true because they are the same, because basically you are asking for this phone here and then you are asking for the Y asterisk phone. It's the same address, it's the same data, they are going to be the same. But only if you do that one first. And use as before with the pointers. The pointer is equal to the address of the data. And from that point below, the pointer is just another name for the same space. Whatever you do with X, whatever you do with Y, you are doing that with exactly the same place. And therefore, you are going to change the data. Good. Now, in this scenario, before doing this, I have the struct and I have a pointer. In this example, I can use the struct to get a name. I can use the struct to get a phone. I can use the struct to get an email. All of this, and even the printing, is okay because I am working with this, with the struct, with the one that have the spaces. So I can put things inside of this or inside here because what I create is a variable for data. That is fine. Then when I do this, I am connecting my pointer with my data. This connection is to the address of the variable. We're working with the structs, but every single rule that we reviewed before with these kind of examples using integers apply the same. Y is going to be pointing to X. And when Y is pointing to X, what I can do is, like here, use the asterisk, right? The Y, the dot, and the name of the variable that I want to use. Now, something that we need to do, and be careful with this, is a common error. If I only put asterisk, Y, and phone, if I do this, by default, the computer is going to apply the asterisk after the dot. The meaning of this is something like asterisk, Y, dot, phone. The first thing that the computer is going to do is this, and then it's going to do the asterisk. But that is not what we want, because phone is not a pointer. The pointer is Y, right? So when you use the asterisk, it is mandatory to do the use of the parentheses, because we want to ask that the asterisk is applied not to the full sentence, but only to the Y. And after you apply the asterisk to the Y, then you want to access, in this case, the variable phone. Be careful with this. You need the parentheses when you are working with pointers to structs, because you want the asterisk to be applied to the name of the struct, not to the name of the struct, dot, and the variable, whatever you are using, unless the pointer is the one that is inside of the struct. Now, a lot of people complain about this. A lot of people says, you know what? I always forgot the parentheses. I never put parentheses. I do something like this, and I receive a lot of errors, and it's time consuming. So the people figure out a different notation, just like with the arrays. You can use the square brackets, you can use the asterisk. Well, when you work with the structs, if you want to do this, instead of using asterisk and instead of using parentheses, what you can do is minus and greater than, but they looks like an arrow, right? But it's minus, greater than. Every single time that you saw in a program the minus and the greater than, the arrow, the meaning is this is a pointer to a struct, and this is the element inside of the struct. So if you have a struct, you can use x.phone. And if you have a pointer to a struct, you have two options. You can use the asterisk, remember the parentheses, or you can use the arrow. And you can be thinking, well, why the arrow? Well, it's like Y, the pointer, and the arrow, and phone is the name of the variable. Arrow, pointers. It didn't work with primitive data. With primitive data, you need the asterisk. But with the structs and later with objects, a new operator, the arrow operator. 2 characters. There is no arrow in the keyword. It's minus and greater than. Every single time that you work with pointers, you're going to be using this one. Most of the people prefer that one than the parentheses with the dot, but they are equivalent. In the same way, most of the people use the square brackets instead of the asterisk plus the index. Options. You can use that for assignation. You can also use that inside of the print. This one is this one. Whatever you want to use, obviously I recommend you this one. Get familiar with the notation. Makes sense? Now, this is easy. We need to use that for data structures. Data structures. The only thing that we haven't included in this full description is Malloc and free. Can we use Malloc and free with the structs? Yes. You can use Malloc and free for a struct, and also you can use Malloc and free for the elements inside of the struct. Let's see. I am sure that you know the linked list. You know the linked list, right? Just tell me yes or no. Linked list? Yes. The green. I have 50 people and 1 yes, so all the others is also yes or maybe. Okay. 2 yes. I am going to assume that 3 yes. Okay, that is okay. Good. So think about a linked list that you already know, and what you have in a linked list are these elements, nodes that you want to connect. Option number 1, if you think about pointers, is each of these is a pointer to the next one. That is a bad idea because when you have a pointer, the next one should be a pointer to pointer, and the next one a pointer to pointer to pointer, and this could become crazy. A better idea is each of these could have inside 2 things. One thing could be a space to store a value, and the other thing could be a pointer to the next element. And that is what we know as a linked list, right? And maybe we need a pointer to the first element. So every single element is 2 things. And one of the things is a pointer to another element. And we put this thing together and we create what you know as a linked list. And this is better than an array because all these elements are not consecutive in the memory. Well, this is better thinking about the possibility of use more space, particularly in the heap, but this is not exactly good because now we are using 2 variables instead of 1. So this is going to use twice the space. Anyway, performance, a different topic. Here, can we agree that each of these boxes that I am drawing, well, I can use a circle, and each of them is an object in Java, but here in C can be a struct, and a struct that you usually name node in data structures. And moreover, inside what you have is 1 variable for the value. I am going to use integers, but you can use names, whatever, an array or something. Let's use integers, use for the example. That is the value. But then you need another element. And that other element is a pointer to the next element. a pointer to something that is the same like this. So a pointer next to this. And I want to be sure that it is clear that inside of a struct node, I can have a pointer to a struct node. I can have a pointer to another element that is the same type that me. Is like the linked list. Every single node point to another node, which can point to another and another and continue. So the first thing that I need to create a linked list in C is this data structure. And moreover, I will be using this library. Can you help me why I'm going to use that library? stdlib is for Malloc and free, right? That is the library that you need to work with dynamic memory, Malloc and free. So my library for that, my struct, and then in some place in the program, what is the meaning of that? Struct node asterisk head equal null. That one is an element that have value and next head. I want to be sure that we agree. This one is head. What is the size of head? Is a pointer. Probably the size of head is 4. It's just a box in which we are going to store an address, which is the size for one of the nodes, probably 8 for the integer plus another 4, the pointer. The pointer is just an address, probably 4. These ones, the nodes, the size is twice the size of a pointer alone, like head. Now, if I have head, can I do something like this? Head, a pointer, equal to Malloc. And if we remember Malloc, something that you need to add there, or you can add there as a good programming thing, but I removed for this because the size of the slide is parentheses, struct, node, asterisk, the casting, remember, the same that we use for integers. So if you're wondering, you can add it there when you copy paste the program. Equal Malloc, and notice what I am asking for. When you use Malloc with variables, you ask for the size of the type of the variable. When you create Malloc, when you use Malloc with arrays, you ask for the size of one element times the number of elements that you want. And now you're going to use Malloc for structs, and it's exactly the same. You're going to ask for the size of the struct in this case. How many elements I am going to create here? How many circles with the 2 variables? And hopefully you agree with me, 1. What happens if I want more? What happens if I want to create an array? Forget about the linked list. What I want is an array of struct nodes. What is the instruction for create an array of 10 nodes in the heap? Can you agree with me that the only thing that you will need in order to create an array is here multiply for the number of elements that you want? It's the same that create an array of integers or an array of characters. Size of 1 times the number of elements that you want. And that array is not going to be in your stack. That array is going to be in your heap. But well, right now we do not want an array. Right now we want a linked list. So I am going to create one, and I am going to connect that one with my pointer head. And hopefully it is clear that with that instructions that are going to be in some place, what I have is a pointer, and the malloc is connecting that pointer with one element that have value and another pointer. That is the only thing that I have. Now, moreover, did you notice these two instructions? Head, arrow, val equal 1. That one is exactly the same that asterisk head parentheses, remember? Dot val equal 1. These two are the same. The arrow look better. Head, arrow, val equal 1. This instruction here help me to put the number 1 in the element that I just create with the malloc. Head, arrow, next equal null. Null is the value for a pointer that is not pointing to any place, and usually is the one that you represent with this arrow go down. This is what I did with the second block of source code. Makes sense. This is null. So the value 1, the pointer null, the pointer head to the first element of the linked list. This is familiar. Now, here, the next step, what else I can do? Well, something else that you can do is, for instance, that line. Can you help me? What is going to be the result of that line? Particularly, can I do this? Head, arrow, next equal malloc. And whatever is the parameter. Let's see. Head, arrow, next. I am talking about this thing here. That one is a pointer to struct. So is a pointer can store an address. So yes, you can use malloc and store here whatever is the result of the malloc. Now, what is going to do malloc? Well, malloc is going to create a new thing, right? A new thing? Yes. What kind of thing? Well, something that is size of struct node. I don't care what that thing is, but the size is the size for something that is going to have a value and something that is going to have an X. Notice, we're going to use value and we're going to use next. The malloc, the only thing that it's doing is giving you the bytes that correspond to these variables. But the names do not exist. The names are used for you in the program. In the memory, in this case, you have 8 bytes. That's it. But you have a pointer, this one, and the pointer is to a struct node. And because the pointer is to a struct node, the computer can check, okay, if I have a pointer to a struct node pointing to 8 bytes, that means that those 8 bytes correspond the first 4 to an integer value and the second 4 to a pointer. That is the reason because you need the data type for the pointer. Now, if I do malloc and I store the address in head arrow next, hopefully you agree with me that what you have is this guy pointing there. And that looks like a linked list with 2 elements. Obviously, I can complete this with these two lines. Head, arrow, next, arrow, val is 2. Can you agree with me that the 2 is going to be there? Can we use this arrow? Yes. Head, follow the arrow, read next is a pointer, follow the arrow, val, 2. And the 2 is going to be there. 2 arrows. Why? 2 arrows in the picture. That is the reason, because they use the arrow. Match the picture. Now, if I can do that with val, I can do the same with next. Head, arrow, next, arrow, next, equal null. Okay. Equal null. My linked list with 2 elements, the last element, the pointer, is not pointing to any place. Do you remember? That is a condition that you have for the linked list. The last element, the pointer, the reference, should be null, so you can do a traversal of the list, and you know when you reach the end, because the pointer do not move you to another place. What do I need to do to add here, instead of null, instead of this, another element, and put this one to null? Could it be possible if I do head, arrow, next, arrow, next, equal, Malloc, size of, struct node? Can I do that? And hopefully everyone agree with yes. This is the same that you did here, and it's the same that you did here. A node connected with head, a node connected with head next, a node connected with head next, next. And you can continue forever. You create a linked list. That's it. Now, you have the linked list. The next thing that you want to do is to traversal the list, to read the elements in the list. I have a source code here for you. Let's see. Can I have a method and that method receive as a parameter a pointer? Parameters are local variables, so yes. If I have a method and that method receives as a parameter a pointer, it doesn't matter the name. Can we agree that what I am receiving there is a pointer to a struct node? And by the way, this head, the type is struct node. So I can send the value of this pointer to any method. You can have this one as a global variable, and then you can have several methods that use that global variable, or you can have methods like this that receive that pointer as a parameter. We need to talk more about parameters, but just to introduce the topic, pointers as parameters, it can be done. Anyway, right now, what I want is to focus on the source code inside of the method. If the parameters are a problem, just think about this source code, copy paste in the same place that you are using all the other source code. The important thing is what I have here is I am creating another variable By the way, struct node. Can I create a variable struct node asterisk with the name current and make that equal to head? Can that be done? And if that can be done, what is the meaning for that? So far, we have this pointer. The name is head, and is pointing to an element that have a value 1 inside, and another pointer, and this pointer is pointing to another element that have a 2 inside, and another pointer, and this pointer is down. And suddenly I am creating something called current, and I am doing current equal head. So whatever is the value here is going to be copied here. And basically that means that now I have 2 pointers pointing to the same address. It doesn't matter which is the number. The idea with the picture is you have 2 pointers, head and current, and both are pointing to the first element here, to this one here. Whatever it is, they are pointing there. Okay. Can I do current arrow next arrow val equal 7? And if I can do it, where is going to be that 7 stored? Is going to replace the 1 or is going to replace the 2? The 2. So are you telling me that you can create a new variable, and just because that variable have the address of the first element, now you can use that variable to change things in the full list? That is the goal of the pointer, right? You can do this. Anyway, we are not going to do that yet, because what we want to do basically is print things. Good. So instructions, I did this, check. I know what's happening in the memory. Now I have a loop while current not null. While current not null, and remember this, we are going to print current val, and we are going to do current equal to current next. Print and equal to the next. Current, this one, is null. And hopefully you agree with me, it cannot be null because it's pointing to something, right? It's not null. Okay, it's not null. So because current not null is true, what you are going to do is to print current arrow val. So you're going to print the 1, current, the arrow, val, the 1. And you're going to do current now equal to current arrow next. What is going to happen with this line? Can I do that line? Can I make equal this pointer to something that is inside of the struct? And the answer is yes, because that something is another pointer and is the same type than this one. So think about it. This one is pointing to an address 0x whatever, that is the address of this one. And what I am doing here is to copy this current arrow next 0x11, and I am going to copy that value in current. So this one is going to be 0x11 now, And the main consequence for that is this current is not pointing to this element anymore. This current is not having the same value that head anymore. What is going to happen now is this one have the same value that this one. So this one is pointing there. Okay. So at this point, the loop is going to go back, right? Remember the while. And I am going to check current is null. No, it's not null. It's 0x11. It's a valid address. So next step is a valid address. I want to print current arrow val. And the most important thing that I want you to notice is now current arrow val is 2. The current, that address, the arrow, and the val here. We change that to 7, so 7. This is the val that we're talking now, because we did this instruction here before. The head is still pointed to the first element, but we're using this pointer like to the first one, I move to the next one, and I move to the next one. And in doing that, I didn't need to do head, arrow, next, arrow, val. Instead of all these arrows, and it's just a linked list with 2 elements, instead of that, well, we are using this current directly with val, because we make current equal to head next, current next, because current and head were the same at the beginning. But also, after printing the 7, I am going to do current equal to current next. So this one equal to this one, the next. This next was null. We put null there to represent the end of the list. So now we're going to do this instruction. And with that instruction, I am going to copy in current the null, this null. And I go back to the loop, and in the loop, current is different than null, is going to be false, and in that point, the loop stops. And what you did with this loop, printing all the elements in the list from the first to the last one, you stop with the null. And moreover, instead of using one instruction with all these arrow, you use one pointer. And basically what you are doing is moving that pointer from one element to the next. So always, the only thing that you need to do is to use the name of this pointer with arrow val, and you are talking about the val here, or the val there, or more, if your linked lists have more elements. Pointers with the structs, with a combination of methods and loops. Any questions so far? Good. So source code. Here, what I show you is the key ideas and the pictures. Going to the source code, the implementation of a linked list in C. I am going to use 2 columns, but you can copy paste this, use column 1 first, column 2 below, and you can have the full program working. Libraries, 2 libraries, the one for the print, the one for the Malloc. That's it. The struct, the same that I showed you before, is not inside of any method, is used usually below the libraries, you put your structs. Then here, I am going to show you first the main, then other methods. In the main, in this case, a main that is integer, I need a return, right? For my main integer, what I am going to do, I am going to create head. It's a good idea to put head in null. So what you have is head in the memory and to null. Question, head, the variable, is in the heap or in the stack? Head. It's a local variable in the stack. Good. Yes. So, yeah, good point. Advantage and disadvantage, arrays and linked lists is something that you are reviewing or will review in the data structure class. As a summary, number one, the arrays. If you want to create an array of 1,000 elements or 100 elements, a big limitation of arrays is the elements should be consecutive in the memory. Remember, the 1, 2, 3, they are physically consecutive in the memory. And think about it. Maybe you have 100 bytes in your memory, but usually they are not going to be consecutive. They are going to be in different sparse in different places. So usually, even though you have the memory, if you ask for an array of 100, even though you have the space, just because the space is not consecutive, the computer is going to tell you, I cannot create your array. You do not have the memory. It's a big limitation asking for consecutive spaces. When you have small arrays, there is no problem. But when you are thinking about big collection of elements, the fact that you cannot be sure to have your memory kind of consecutive, clean, is going to be an issue. So in that point, you use linked list. With the linked list, because you have these pointers, the elements are not consecutive. You have a pointer to the next element. So the first element can be here and the second element here, and it doesn't matter. Every malloc is asking for the size of one element. Every malloc, as I showed you before, is asking for 8 bytes, and it's going to be easy to find 8 bytes to put the node and another 8 bytes in a different place instead of 16 bytes consecutive. So that is one advantage for the linked list, the fact that they work with memory that is not consecutive. That is advantage. The disadvantage, as I mentioned before, the performance. With the linked list, an easy example, if you have 2 nodes, you are using twice the memory. In an array, 2 elements could be 8 bytes. If the array is integers, with the linked list is twice that because you have the value and you have the pointer. So it's a balance, which one you use. Yeah, of course, I am going to show you that. The loop in which I am printing, you can apply the same idea to create the nodes. You can have a loop that creates a linked list with 100 nodes, and maybe the information comes from the user, or maybe the information comes from a file. Putting things together, programming, right? So in my example here, just to be sure that we agree with things. Number one, I have the main. In the main, I am creating head. The head at the beginning is going to be null. I need you to remember this. In your exam, use paper, draw what is happening in the memory. That will help you to answer the questions and be sure that your answer is the correct one. Paper and do the draws is useful. So step number one, head equal malloc. That is a malloc that we have been using a lot. Hopefully it is clear that malloc is going to create a node. The node have a val and an x, and this guy is going to be pointing there just because this equal. Then the val equal 1. Now it's going to put a 1 there. Then this one equal the same malloc as we reviewed before. A second node here, and this one is going to be pointing there, the val and the next. This one, the number 2 is going to be here, and this one to make null the list. The same instructions that we explained before. Now I am giving you the code. Those instructions can be in a main, and this is what you are doing. Now, then, I have some methods here. And I have homework for you. What is happening to those methods? Number one, I have a method push and I have a method pop. They are my methods or they come from a library. They are mine because I haven't mentioned any library that have them. So I need a method push and I need a method pop. And I want you to notice which are the parameters. Tell me, how many parameters for a method push? Moreover, tell me, which is the data type for each of those parameters according with these examples? Can you agree with me that push is a method, maybe void, push, 2 parameters, and something is going to happen inside? Types for the parameters. The second one looks like it's just an integer. The first one, a struct node. Could you agree with that? Head, a struct node. That is going to be the parameter. Pop. What do you think is going to be the parameter, the data type of the parameter for a method pop? Have only one parameter. I am sending ampersand head. What is the data type that is the result of ampersand head? The address of head. And what is the data type to store the address of head? Struct node, yes, with one asterisk, like a pointer to a struct, or maybe, use maybe, 2 asterisks. I am sending the address of head. If I send the address of head, what I am going to be doing is pointing to head, but head is a pointer. So could you agree that pop have as a parameter a pointer to pointer in order to receive the address of a pointer? If I send head like I did here, the parameter here is a pointer to a struct. But if I am sending the address of head, this should be something different. The data type for the variable that receive head and the data type for the variable that receive ampersand head should be different. Take a look to this code. This is push, this is pop, and this is print list. Review this code. We continue next lecture. Good? Any question? Okay, thank you guys. See you next week.